So today we're going to look at how we find the equation of a tangent of a circle centre 0, 0 and how we solve problems involving that tangent. So let's just look at very basic tangents first of all. So I have x squared plus y squared equals 36. So I've got a circle, centre 0, 0, radius 6. If I look at the point 6, 0, I can see that my tangent there is going to be a vertical line going through x is equal to 6. Let's put that through x is 6. So the equation of that tangent then will simply be x equals 6. At the point 0, 6, so that's up here, I can see that my tangent there is going to be a horizontal line through y equals 6. So again, quite simply, the equation of my tangent at 0, 6 is y equals 6. What about then when we don't have a vertical or a horizontal tangent? So here I've got x squared plus y squared equals 25 and I want the equation of the tangent at the point 3, 4. So we need to remember to find the equation of a straight line, we always need a point on that line, which we have. That's the point 3, 4. So we've got that piece of information already. And then we need the gradient of the line. So we need to find the gradient of that tangent, and then we'll be able to use the general formula for the equation of a straight line, y minus y1 equals mx minus x1, in order to find the equation of the tangent. So to get that gradient that we need to remember an important circle theorem. The tangent is perpendicular to the radius. So if we actually just pop a radius here on the diagram, we know that, there we are, we have a right angle there. So if we can find the gradient of the radius, we'll then be able to find that gradient of the tangent that we need. And that's the approach that we're going to take. So let's follow those steps through. First of all, I want the gradient of the radius. So we can use our gradient formula, y2 minus y1 equals x2 minus x1, but one of the coordinates is 0, 0. So actually it might be more straightforward just to draw in a gradient triangle. And I know my horizontal distance is 3 and my vertical distance is 4. So the gradient of my radius is 4 over 3. I can then get the gradient of my tangent because I know it's the negative reciprocal because they're perpendicular. So the gradient of the tangent is minus 3/4. So now I can find the equation of the tangent. I've got my point 3, 4 and I've got the gradient of the tangent minus 3/4. So I'm going to substitute into y minus y1 formula. So let's just do that now. So I've got y minus my y coordinate, which is 4, equals my gradient minus 3/4, x minus the x coordinate, which is 3. Now, it doesn't say what form it wants this equation in, but I am going to rearrange it a little bit. So I'm going to get rid of this fraction by cross multiplying the 4 over the other side to give me 4y minus 16 equals, and I'm going to expand this bracket, minus 3x plus 9. And then if I take the x on the other side, I'm going to get 3x plus 4y is equal to 25. So that is the equation of my tangent. Now let's just link that to for a moment. This is a tangent to the circle x squared plus y squared is equal to 25 at the point 3, 4. Now let's have a look. Do we notice, let's see if we can get some different colours here. This 25 shows up in the equation of the tangent here. My x coordinate of 3 shows up in my equation of my tangent as the coefficient of x. And let's have one final colour, let's have the black. My y coordinate of 4 shows up in the equation of my tangent there. So when we are finding equation of tangent centre 0, 0, once we've got the point, we could write down the equation of the tangent in this form. However, you do need to be showing your method as to how you found it, but that's the way you can check that you are correct. Let's have a look at a slightly harder example then. So here we've got a circle centre 0, 0, radius 10, because it's x squared plus y squared equals 100. We've got a tangent again at 8, 6, and we can see that the tangent crosses the x-axis at this point A. And what it wants us to do is find the area of triangle OPA. So the first thing to do is to actually draw in the triangle. So we've got OPA. So this triangle here that I'm interested in. Now when we're solving problems with coordinate geometry, it's best to think backwards and think, what do I need, and work our way backwards. So we want the area of that triangle. So how are we going to find the area of the triangle? What do we need? Okay, so if we look at this little diagram of my triangle here, if I'm going to use the formula for the area of a triangle, base times height divided by 2, I can see here I've got the perpendicular height of the triangle, because if I draw that in over here, that's simply the y coordinate of P. So we already know the perpendicular height, so actually what I need to find is that length OA, which is the base of my triangle. So if I need OA, actually what I'm interested in is finding the coordinates of this point A, where it crosses, where the tangent crosses the x-axis. So if I want to know where the tangent crosses the x-axis, so we want to find the x-coordinate of A. So in order to do that, I'm thinking backwards again. I'm going to have to find the equation of the tangent, and if I substitute y equals 0 into the equation of the tangent, I'll find out where it crosses the x-axis. Right, let's follow these steps through them. So I'm going to need the equation of the tangent, so we're going to go through that process again. So I'm going to get the gradient of the radius. So the gradient of the radius is going to be the 6 over the 8. So I've got 6 over 8, and I'll simplify that to 3 over 4. Gradient of my tangent is perpendicular, so I want the negative reciprocal, minus 4 over 3. Now I'm going to substitute into my y minus 1, y1 formula to get the equation of my tangent. So I've got y minus, what point am I using? I'm using the point 8, 6. So I've got y minus 6 equals the gradient of my tangent, minus 4 over 3, x minus the x-coordinate of the point I'm using, x minus 8. Right, again, let's tidy this up. Take the 3 over cross multiply, 3y minus 18, expand the brackets, minus 4x plus 32. Take the x term and collect the y term as well on the left, and the number terms on the right. I get 4x plus 3y equals 50. Let's just pause for a moment there and see if what we noticed last time is true. So if I multiplied everything through by 2 here, that's equivalent to 8x plus 6y equals 100. And I can see again there, I've got the 100 is the same as the 100 in my equation of my circle. The 8 links to the x-coordinate of my point, and the 6 leads to the y-coordinate of my point. So I know that that's right, but I did need to show my method. So now we've got the equation of the tangent, we said, well, we can then work out the x-coordinate of A by substituting in y equals 0. So let's do that now. So substitute in, I've got 4, I'm using 4x plus 3y equals 50, but if I substitute y equals 0, I get 4x equals 50, or x is equal to 50 over 4, which is 25 over 2. So I now know that in my triangle, the base of my triangle is 25 over 2, and I've got that perpendicular height of 6. So to find the area of the triangle, I'm simply going to do half times the base times the perpendicular height. Let's simplify a little bit. So if I cross cancel that 2 there, that becomes 3. So I end up with an area of 75 over 2 without a calculator needed. Okay, I want you to have a go at this question. Okay, so pause the video, have a go. I suggest you probably want to draw a quick sketch of the circle and imagine what's happening in your head. This time you want the equation of your line in the form y equals mx plus c. Okay, so if you've had a go of that, first of all, you're going to find the y coordinate of the point you want the tangent in. So substitute x is -5. It says it's the positive y coordinate, so we want that plus 12. So we're finding the equation of the tangent at -5 plus 12. So gradient of the radius, -12 over 5. Gradient of the tangent, 5 over 12. Substitute into y minus y1 formula. Rearrange, and this time, rather than stopping up here, we're going to just rearrange to get it into the form y equals mx plus c, which means we need to make y the subject of the formula, and this is the answer that you should get. Okay, your turn. So, equations of tangents worksheet, challenge start on question 1, or super challenge, you can just do 1D, 2, 3 and 4, and then move on to hyper challenge. So either start on challenge or super challenge.